Hello, my name is Mario Sanchez, and today we'll be discussing about the Chapter 3 Math homework and Chapter 3 Math lesson that we were going over this week. And I'll be discussing 3 points and 3 other points. The first 3 are going to be things that I've learned from this chapter, and the other 3 are going to be things that I really need more help on or more clarification on. And now we're going to be starting our first part, which is going to be the 3 points that I understood from this chapter. Alright, so one important thing that I found from this chapter was, for example, trying to plug in polynomials or trying to put in numbers back into polynomial form. This is what we learned in 3.1, and this was for me something that I really did not know until we started finally doing them. And I like to give an example by going through the homework. The first part, for example, was g of x equals 2x minus 3 plus 3x squared minus 5x plus 1. So this is what our first problem of our math equation was, and when we trying to find the x, our x was given, which would equal 12. And one thing that I learned how to solve this was pretty much plug this number back into all the x's. Fill in the squares. So you go like this. G of x equals to negative 12 thirds plus 12 squared minus 5x, or minus 12 plus 1. Let me fix that. And after we plug this number back in, we pretty much get every single individual value, and we just get it back in. So for example, the negative to the negative 12x, this would have to be 1728 plus 3, and we have to find the factor of this, which 12 to the second power would equal 144. Negative 144, because we're talking about a negative 12. And we would have to do plus or minus 60. Let me correct my mistake. Minus 60 plus 1. After we find this section, we would have to replug in the numbers. For example, 1728 plus 3 times 144, which would equal 432, minus 60 plus 1. And then after this, we combine these terms to get 2,160 minus 60 plus 1, which would equal to 210.01. This is what I understood from the first part of the chapter. So now, we would like to go to 3.2. 3.2 was pretty simple for me to understand, and I felt like I could understand 3.2 in its entirety, basic. So, for example, we have a problem that involves 3 terms. We have a 4 minus 5x, 1 minus 2x, 1 minus 2x, and 3x plus 2. So, how do we solve this? Well, first we get our 2 like terms right here, and what we have to do originally is, with this, we would have to, as my first step, make a FOIL method on this. So FOIL method consists of a box and 4 squares. Now, with these 2 squares, what we do is we plug these numbers in. So for example, we have 4 minus 5x, 1 minus 2x. Now, the best strategy would be to do FOIL method, because if we try to solve this entirely, this would be more difficult than what it needs to be. So what we need to do is basically focus on two terms, and then we can solve it using this term, because we still have to multiply these two values. Now, I would say using FOIL is the most important, because if you have your term ready and listed, you won't complicate yourself into finding these two problems. So, how do we solve this? Well, 1 times 4 is 4. 1 times negative 5, because this is a negative, we'd have to do negative 5x. And negative 2 times 4, it would be negative 8x, because we have a negative and a positive. And after this, we would have to do our two negatives. Now we know that negative times a negative is a positive, so 5 times 2 is 10x, and because there's two x's, it would have to be 10x squared. Now that we have our problem right here, it would be 4, negative 5x, negative 8x, and negative 10x. Okay, so after we finish our FOIL method, what do we do? Now, what we do is we pretty much get all our values and we just put them back into an equation. Now, what do we notice here? So what we notice there is that these are two common terms right here. Now, with common terms, what could we do? Well, we can add them. And because negative 8 minus 5x, that would equal to negative 13x. So we would be having a new equation of 10x squared minus 13x plus 4. So this would be our new problem. And after this, what do we do? Well, we just drop this value down, and we do 3x plus 2. This is way easier to understand now, because now we know that we can simply just separate these two, because it's technically a square, and we can just make them into two problems. So we can use this, and we can put it back into this. So it'll be 3x, and 10x squared minus 13x plus 4, and 2 times 10x squared minus 13x plus 4. And now we're going to be going to our solving part. Okay, so now we got here our two problems. So because we know that we distributed the 3x plus 2 into two different problems, now what we could do is that we can distribute the 3x across the whole board. So what do I mean by across the whole board? Pretty much you just go like this. You distribute this value into multiple spaces. To distribute this value into multiple spaces, what we would have to do is, for example, so these are 3x times 10x squared. This would have to come out to 30x cubed. Now, why 30x cubed? 30x cubed is because 3 times 10x, or 3 times 10, is 30. And because we're multiplying also cubes, we would have to add a 1, invisible 1, to a 2, which would equal to x cubed. Now, after this, we would have to continue on. For example, 4 times 3, which would equal to 12. 12 plus 12x minus, because we're dealing with a negative here, minus 39x squared. So we have our first problem. Now, we have to distribute this one across the board. Distributing this would have to come out to 2x, so it would have to come out to 20x squared, because we're not dealing with another x. So this would have to be its own independent variable. And now 2 times 4, it would be equal to 8. And 2 times negative 13, which 2 times negative 13 would equal to 26. negative 26x. So from here, what do we do? Now we see that these are two problems. How do we go with these two problems? Well, easy enough. Okay, so now what we have to do is that we would have to add these two terms. Now we know that if we add these two terms, we would have to combine like terms. Values that have the same squared or same cubed values. It has to be the same, because if we add them all that are not different cubed, it's going to become a whole disaster. Now a better strategy for this would be just not cancel, but just find the terms that are easier for you. Right here, 2x and 2x. And what we have to do in this problem is we can't randomly put, for example, 2x, x, and 3x. No, we have to put them in order. So for example, 30x squared would have to come out first. Why 30x squared? Because there's no other cube. There's no other cubed value in here. And 20 plus 30, negative 39. And if we add them, that would be negative 19 squared. And x plus x, because it's a negative 26 plus 24, it would have to come out to negative 14x. And a, its independent variable, would have to come down here. And with this, we solved 3.2, one of the master problems. This would be our answer. So I solved my problem by basically using the FOIL method. And another way that we could solve this problem is by approaching with the FOIL method and approaching with distributing. Because we know that there's three different terms that we first had. And what we have to do is that we have to simplify those two terms into only two terms that we could solve easily and distribute across the x. This is way easier and way more understandable than having to solve it with the three terms that we have to solve with. And this is how we get our answer, and that's how we solved a 3.2 problem. Okay, so now we'll be going over 3.3, what I understood from this chapter. So the main thing that I understood from this chapter was learning how to do long division. So long division, for example, this is our homework right here. We had this as one of our homework problems. So what is long division? Long division is including this line right here and having a variable or having a number up here which would equal this. So how would we approach this? So we would just do 2x minus 3x minus 2 as our outside. Inside is different. Inside it will have to be 4x4, and there's something missing over here. So what is missing? The terms cubed and squared. So how do we fill it in? Well, we just do a 0x cubed plus a 0x squared plus 5x minus 4. So from here, what do we start to do? We break down this. So we know that 4x4 can be broken down into 4x cubed times x squared. My bad, I mean 4x squared times x squared. And we know that if we do right here 4x squared, we would easily be able to multiply this across the board. And we would get 4x4 plus 0x cubed, 12x cubed, plus 8x squared. Now, what do we do from here? We pretty much just cancel out these terms because this is technically subtracting. And we would have to make this negative 12x into a negative 12x plus 8x. We would have to make it a negative 8x. So we have to cross out those two terms first. And we would have to get 12x cubed plus 8x squared. And drop these two variables down. 5x minus 4. this is what we would have to do. So a better strategy to this problem would be just to find what common variables fit into each category. Because if we use these common variables to fit into each category, we'll be able to solve this problem more efficiently and more easily. I predict that if we use these variables exactly how we're breaking them down, we'll easily find our problem and easily be able to solve what we're trying to solve for. So now we're going into this. Exactly what we did here, we would have to do here. So it would be 12x cubed. Now, it would have to be a mixture of 12x squared plus x times x. So we would have to do the 12x. So it would be plus 12x. And once we do 12x, we know that 12x plus x squared will be equal to 12 cubed. 12x minus 3x would equal to negative 36x squared. And negative 2 times 12 would equal to negative 24x. So as we do the same, we cancel out these terms. And we have 8 plus negative 38. Or 36. Apologies, 36. And with 36, what we'd have to get is 44x squared plus 29x and minus 4. So once we get this variable, we know that there's only a few more steps to solving this. So now we would have to break down 44x squared. Now 44x squared can be broken down to 44x times x squared. And then with that we'll get plus 44. Actually, my apologies, it's times x squared. So now we'll have 44. We know 44 plus x squared is 44x squared. 44 times negative 39x would equal to negative 132x. And 44 minus 22 would equal negative 88. So after we solve this, we get our answer of 161x plus 84. Because we canceled out these two. So 161x and 84. That would be our first part of our solution. And now we're going to be moving on to our next part of our solution. Okay, so now that we have our problem solved, well, our first part of our problem solved, now we would have to plug it back into the equation. Now, how could we do that? So, this is because, I believe this is true because what we have to do is we have to redo the whole problem, including 4x squared, which was our beginning problem, 4x squared, plus 12x, plus 44. That would be our top solution for trying to solve for long division, which then would equal to 161x plus 84 over x squared minus 3x plus, or not plus, negative minus 2. And this would be our final solution. The ideas, we can use the core principle of trying to resolve everything into its long division form, where this problem would be our second part of the long division. Here's our first part, or our solved part of the long division, and our answer. So once we have all these four components together, we can make a theory and we can make it logical, where this would be our problem and this is how we solve it. Now, after this, this would be all of what I understood of this chapter. Now after this, I'll be discussing of the 3 things that I didn't understand from the chapter and I hope to learn soon.
Alright, good afternoon, Mr. Kagi. Today I'd like to explain my 3 problems that I didn't understand from this chapter. I'm moving it on to Ziteboard because I feel it's more convenient for me to put on the problems here. In my opinion, basically 3.4 was the start of my problems where I felt like everything was becoming a bit difficult for me. One example has to come directly from trying to factor in problems. I would have an issue, for example, having 4a fits equals to, not equals to, minus 108a squared, or a cubed. So this would be one of my issues that I would be dealing with. And for example, this problem really had me a lot of issues with. So I do know the basic concepts. We have to find out pretty much what number fits with that number perfectly to get it into a factored state. That's what I do understand from a problem, but from another perspective, I do not understand how to do these problems. These are the problems where I would feel like it would be great if you could probably explain it a different way, because factoring for me wasn't that much of an easy job for me. I do understand this concept maybe from separating 2 variables from each other. And one example is I could solve it like this, where I can find 2 ways, probably by dividing 4a cubed and having x squared, or k squared minus 25. Not k squared, a squared minus 25. We would have to do like a 3 minus 2. That's how I would understand it. And these are usually problems that I would be have more difficulty with, and that would be basically the issue with me with this chapter, was trying to solve these polynomials while also trying to figure out how to do these problems. And this would be basically it for 3.4. So I like to move on to 3.5. Alright, Mr. Kagi. So 3.8, I like to explain that when we were doing the mathematics, I was wondering, how did you find your answer basically for 3.5? One example has to come derived from, this is just one example that we got from the homework, 3x cubed minus 25x squared plus 58x minus 40. Alright, so basically what I'm very confused on, my point of confusion on this problem is, what did you mean by you said trying to factor out these variables? So for example, this is what I would do in my homework. I would get 40, and then I would make a graph like minus 40 that would be separated into 10 and 4, 5 and 2, 2 times 2, and 5 times 1, and 2 times 1. That's what I would basically figure out from this problem, but how it's worded, it would be very difficult for me to try to solve this. And because this is a 3x right here, I would have to do 3, then 3 times 1, which is just the same as 3 times 1. Which that basically solves that part. So basically trying to get the p and the q, I know that we have to try to do a p and a q equals, but when trying to solve p and q, I would wonder, because there's a 3 and 1, would we have to do this term, for example, 40 and 10, 5, 4, 2, and 1? This would be 1, 1, 1, 1, 1, and 1. And then we would have to do the same. Let me fix this. We have to do the same, where it would be 40, and 40, 10, 5, 4, 2, 1. and it'll be 3 over 3 over 3 over 3 over 3. So this is how I would solve it, but I was very confused on this after. So for example, then I would be super confused on how to get all these variables together. I know that we have to use the long division, synthetic division. That would be easier, and we would have to get our terms from Desmos. So Desmos, and our terms from Desmos was 5. And I saw that during the notes he did 5 and -5, and I was very confused. And I was, how did you find the 5 and -5? Is it almost like x plus 5 to the squared? We would have to do each of the variables twice. And that's where I would be confused on this chapter on 3.5. And this was basically how I would go at it with the homework. If you could probably help me try to reword it somehow, try to explain it in a different way where I would probably understand, that would be great. But I like to comment that I like the way that you did help us with trying to solve this problem, mostly using Desmos on this. But at the end of the day, I feel like it was very confusing for me, and I feel like it would be better if you could ameliorate this problem. Thank you. Okay, Mr. Kagi, now for my last example. This would have to come from 3.6 directly. And in my opinion, I feel like 3.6 was pretty simple, the last two examples, but example 1 was very difficult for me to understand. And I like to first use the one that you gave us as a note, example 1, to find how many solutions does x4 plus x3. Let me get this. x4 plus x3 plus 8x equals to 0. And this is derived from the notes for 3.6, where we have to find as many solutions as we can. So I was confused basically on this part. So once we try to solve our solution, let me write it down. We would know that this and this would derive from x4 plus x3. And then, let me see. We would have to add the 8. So let me do it, plus 8. And we know that this would be another one, which would be 8x plus 8. So after we derive from that problem, we would have this problem, which this would still have to go back to 3.4 on trying to divide polynomials. So it was a bit confusing for me, but I did seem to understand it, where it went from x3 parentheses x plus 1. So we have to separate the x4, I imagine, and plus 8 times x plus 1. And I think we did this because if we multiply 8 on each side, it would give us the amount of terms we would need. So then after this, we would have x cubed plus 8 equals to x plus 1. We would have that. And then right here, I see that you marked it as x1, x equals to 1. And even more down here, you would have to do x3 plus 2, 3. And this would have to be x plus 2 and x squared minus 2x plus 2, 2. So we would have that, and we would have to make it into the format of a cubed plus b cubed equals to a plus b, a squared minus ab plus b squared. So we would have that. So I don't understand, from this point to this point, how did you get from here? How did you get this problem? And how did you get this problem? Yeah, how did you get this problem to get this? A equals to 1, b equals to -2, and c equals to 4. So this would have to come from the a, b, and c. And I was very confused when trying to do this, because then you moved on to the Pythagorean theorem, but the issue was I didn't understand how to do this. So basically, what I would want is if you could probably explain and repeat how you got to this process. And additionally, could you give me another example? And I would have to I would have to say that in my opinion, or how I think or imagine the situation, as this would have to be a term that would be multiplied or crossed out based on the solutions in the parentheses. That's how I would interpret it. But if there's a different interpretation you can give me for 3.6, that would be great. And this would conclude my video project. And I hope that you could probably explain these better to me next time. Thank you very much, Mr. Kagi. Have a great day.